Okay, hi, my gems. We are going to talk a little bit today about linear real world situations and some constraints that go along with them as well. So, we're going to talk about both linear equations and linear inequalities. So, remember, an equation means that it's going to have obviously an equal sign. If it's an inequality, that means you've got that greater than, less than, different symbols within your equations. And just as a really quick reminder, I know we just did this, but again, if it's a greater than or less than symbol, there's no equal to sign. That is a dashed line. It also means that those solutions are, or those points on the line are not included in the solution. If you have a solid line, that means you've got greater than, less than, with equal to's underneath them. And again, if it is a solid line, then the points that are on the line are included in your solution. So what we're going to do now is really look at some word problems, which I know you guys love so much. And we're going to do some practice writing equations based on word problems. And you are definitely going to see this on your EOC, so not something to skip over. Okay, number one. Paul needs 27 plants to fill his garden and has $99 to spend. Lilies cost $5 each, and tulips cost $2 each. Write a system of equations that represent the number of lilies, L, and tulips, T, Paul can buy. Now, already I see system of equations. So that means I should have equal to symbols, right? No greater than or less than, anything like that. Typically, we are asked to define the variables, but I see that they've already defined the variables for me here. So L will mean number of lilies, and T will be my number of tulips. Okay, now I know in total Paul needs 27 plants to fill his garden. So already I know I can write one equation that just says the number of lilies and number of tulips needs to equal 27, right? That's easy peasy. So number of lilies plus number of tulips equals 27. Okay, there's my first equation. My second equation, so this is all about like how many, right? This is my number. Whereas my next equation is now really going to focus in on pricing. So I see I've got $99 to spend. I see lilies are $5 and tulips are $2. So I'm going to write an equation now as my second one that's all about the money, the dinero. So I know each lily is $5, each one. So anytime you see this word each, or you might also see like $5 per lily, that means we're going to be doing multiplication. So each lily is $5, so 5 times the number of lilies, or 5L, plus I know my tulips are $2 each. Again, this is each or per means we're going to multiply. So 2 times T equals how much money do I have in total to spend? He's got $99. Those right there are your systems of equations. That's it. Boom, you're done. Doesn't ask me to solve it, just asks me to write it. Now, obviously, when you get to, you might have to solve them, obviously, on a test. But for right now, just practicing how to actually write them is like half the battle. Okay, easy. On to the next one. Example 2. Central High School is hosting a fundraising event. The venue, decorations, and disc jockey cost $1,400. The venue can hold at most 300 students. Tickets cost $20 for a student and $30 for a non-student. Let S represent the number of student tickets sold, and let N represent the number of non-student tickets sold. So if the school wants to earn money on this event, which system of inequalities represents the number of tickets that should be sold? So I'm not even going to look at the answers. I'm going to do this myself, and then I'm going to see which one matches up with what I've got. So just like how I did before my last problem, my first part of this is going to be all about how many can I have, right? Like a total number. I'm not looking at price yet, just looking at the how many. And so what I'm going to do is I'm going to go through and just highlight all the information that is about how many. So the venue can hold at most 300 students. The rest of these are prices. The only other piece I see is definitely my variables. They've already defined my variables for me. So I can already write my first inequality / equation just based on that information. So I know that if I were to add together the number of student tickets plus the number of non-student tickets, it would have to be at most 300. Now, most, remember, means max. That's the maximum capacity. It cannot be bigger than 300. It can equal 300, but it can't be bigger than that. So it has to be numbers equal to or less than 300. Right? Because I can't pick something bigger than that. So already there's my first equation for how many, when I'm writing equations. You're always going to have one about how many, you're always going to have one about money. So that's kind of how you can think about writing your two equations. So already as I look at my answers here, this one's wrong and this one's wrong. So already, oof, look at me. So fantastic. So now the question is, now I need to do my money one. Okay, so I did money now in a different color. So money. Okay. I know that the venue, so everything costs $1,400. So I can't go over $1,400, right? It has to be less than that because we're on a budget, right? Balling on a budget here, okay? So tickets cost $20 for a student, $30 for a non-student. So I'm going to come down here. I'm going to write that as an inequality. So $20 for a student. So 20 per each student means, again, we're going to be multiplying. So for student, that is the S. So I've got 20 times S plus $30 for a non-student. And we know that it has to be, we want it to be greater than that 1,400. And the reason we're going greater than is because we want to make money. We want a profit, right? So in order to make a profit, we would have to sell more than that 1,400, right? Like, yes, that is our budget, but because the question's asking me if I want to earn money and a profit, so it's really good I reread this question, right? Earn money, make a profit, that's going to tell me that this is a greater than 1,400. Dollars is how much money I'm trying to spend, or trying to make, excuse me. So looking at this problem, which one matches? That would be the first one. So this is my final answer. Okay, beautiful, done. So you got one equation for how many, one equation for the money. All right, example 3, same thing. Okay, a carpenter makes wooden chairs. He has enough wood to make 30 chairs. He makes $60 profit on a dining chair, $90 profit on a rocking chair. It takes him 1 hour to make a dining chair and 2 hours to make a rocking chair. He has only 40 hours available to work on the chairs. He wants to maximize his profit given the constraints listed. He draws the graph below to represent his situation. So already I see he's got a graph for it, which is great, which means I really don't have to write an equation, a system of equations. I'm still going to because I think it's good practice, but because the graph's there, like if this was your exam, you wouldn't have to write an actual system of equation. So I'm going to start by just defining my variables. I'm just going to do X is my number of dining chairs. And then Y will be my number of rocking chairs. Okay. So now I know he has to make, right? He's looking to make, he can't make any more than 30 chairs. That's his maximum amount, but he is allowed to actually make 30. So that means it's going to be less than or equal to 30. So my first one, remember, is all about the how many always. So for my how many, come on, this pen, guys. Oof. Okay, so if I were to add to both the dining chairs and the rocking chairs, X and Y, it would have to be less than or equal to 30. Okay, so we're talking about how many can we make. Now, my next one's going to be all about money, dinero. So I've got $60 profit on a dining chair, $90 profit on a rocking chair. So if I'm talking about my money equation here, he gets, this is per, right? So each dining chair, he gets $6 per. So that means, again, we're going to do multiplication. So $60 for each dining chair. So $60 per dining chair plus I've got $90 per rocking chair. And that is going to give me my money, but it doesn't actually tell me how much. It just says he wants to maximize his profit. So really, this is like an actual equation here because this is going to equal my profit, my total amount. Now, the other piece that we are not really talking about is the number of hours that it takes, but I don't really need to worry about it because I already see, like I said, I've got the graph already listed here. Now, we know in a system of equations or inequalities, where the lines cross, where they intersect, is the solution to my equation. So mine intersect right here at this point, 20, 10. And the question is, what does that stand for? So the 20 stands for, on my x-axis, my number of dining room chairs made. So this is number of dining chairs. And then my y value is going to be the 10, which is my number of rocking chairs. All right, so the point where they intersect is your solution, which is why I'm saying, like, I didn't even need to write this equation. Again, I just did it to help you out. But if I'm looking at this problem, given the constraints, the carpenter can maximize his profits by making how many dining chairs? What's the solution? We just said 20 dining chairs and 10 rocking chairs. Okay, so that's the solution to my equation. Now, his total profit for the chairs will be how much? Well, I did write an equation for profit. So all I'm going to do is take these numbers, 20 and 10, and I'm going to substitute them in to the appropriate variable for the problem. So $60 for each dining room chair, and he makes a total of 20. So I'm going to plug in a 20 here. Plus $90 for each rocking chair he makes, and he makes a total of 10. So when I do this, I'm going to get what his profit is. Okay. So 60 times 20, 1,200 plus 900. So when I add those two together, I get his profit is a total of $2,100 is his profit. So that is, haha, right there. Beautiful. So look at that. Miss Massa did all that extra work to write those equations. You didn't need it, but on the plus side, at least helps you out. So definitely always read the question, see what it's asking, because I probably could have skipped all of this work and just went straight to looking at the graph. Okay, so go ahead and pause the video, and now you are good to go on your final practice problems. This was the last video, so have a great day.